Open up Visual Studio Code, Electricity and Magnetism. Click this button 037, Clipping Plane. Click this button, Clipping.cpp. Hit Enter. Ctrl V. I will close Welcome window. I assume you have watched my previous videos listed here. In this episode, we will learn from OpenGL Programming Guide 7th edition, Chapter 3, Manipulating Matrix Stack. If you scroll down, you can find a clipping plane code example. We will test this code. Now, in the clipping.cpp, include CPG, STD extensions. Include GL, free, glut, void, init, GL, clear color 0.0, 0.0, 0.0, 0.0, GL, shade model, GL, flat, void, display 1, void, display. We call this function here GL flush. In the display 1, GL double GX plane. This is array. Here I will draw coordinate system like this. This is positive x-axis. This is negative z-axis into our screen. This is positive z-axis out of our screen. Plane equation A C dot MITx alt Q plus B C dot MIT Y C dot MITZ plus D equals 0 alt Q. This is our plane equation. Now, in this equation, we set A, C, D 0, A 0, B 1, C 0, D 0. Or this equation becomes 0x, 1y, 0z, z. From this, we can say 1y should be 0. So, y can be any value. That is, gx plane GL double YZ plane. Now we set 1 0 0 0. From this equation A is 1 because this one represents this one, the value of A. Then B is 0, C is 0, D is 0. From this 1 dot X should be 0. I made mistake here. That is YZ plane. In this case, Y should be always 0. In this case, X should be always 0. Now, with this, GL push matrix, we store model view matrix on the matrix stack. Then GL pop matrix, we restore model view matrix. In between, I will scroll up GL clip plane, GL clip plane 0. We set GX plane. We will enable GL enable GL clip plane 0. We will also enable GL plane 1. Now GL clip plane GL clip plane 1 YZ plane. Now glut wire sphere. I will set 2.0 for radius. Then 40 slice, 20 stack. Before we draw, we will clear GL clear GL color buffer bit GL color 3F. This is drawing color. Our clear color is set here, black color. We erase with black color using GL clear color. In this case, this is our drawing color. Now for the reshape into width, into height. GL viewport 0 0 width height. GL matrix mode, GL projection, then GL matrix mode, GL model view. In between, GL load identity, make projection matrix identity, glue perspective, field of view 60 degree. Aspect ratio width over GL plot height. This is aspect ratio. Near Z 1.0, Z par 20.0. Now int main, int argc, character pointer argb. We initialize glut init by passing argc argb. Glut init display mode. Glut single glut RGB. Glut init window position 100 100. Glut init window size. I will set 600 600. Glut create window. This is window title. Clipping plane. Now we call init function. We defined this init function here. Scroll down. Then glut display function display. Glut reshape function reshape. Then glut main loop. Y is squiggle. Let's go up. This is typo display. With this, open up your command prompt. cd 037 clipping plane nvcc sed c++20 clipping.cpp on.exe. Hit enter. cls n. This is our drawing. Too big. Close it. I will make the radius smaller. We will rebuild. cls n. I can't see anything. What's the problem? Please understand that our model is at the origin here. Also, our camera is at the origin, so we cannot see anything. We can translate our sphere like this. GL translate 0.0 0.0 negative 5 unit z-axis. This negative z means that we are moving our sphere at origin 5 units in the negative z direction around here because our camera is located at the origin. So move sphere 5 units negative along the z-axis. With this, we build again. cls n. Now it is visible but too small. I will restore it back to 2 unit radius. With this, We build again. CLS N. Please understand, we are observing this sphere from the Z-axis. Our camera is at the origin, watching into negative Z-axis. The center of our sphere is negative 5 units on the Z-axis. So this is correct. We will perform rotation. We will rotate GL, rotate 90 degrees with respect to x-axis. So 1.0, 0.0, 0.0. Rotate our sphere 90 degrees with respect to x-axis. With this, we build again. CLS N. This is now our rotated sphere. Now, let's do one more experiment. I will copy this function up to this point. Paste. I will rename display 2. Scroll down. In the function display, we will call display 2. Now scroll up. In the function display 1. Here we will translate positive 1 unit. Move our sphere 1 unit along the x-axis and 5 units along the negative z-axis. In display 2, we translate negative 1 unit. Move a sphere negative 1 unit along the x-axis. 5 units negative along the z-axis. Then we rotate with respect to y-axis. With respect to y-axis. With this, let's try. CLS N. Wow, this is our sphere. I will translate negative 2 unit and rotate y and z axis. We can do arbitrary experiment. CLS N. This is our result.